Hi everyone, I Mutung Gopal Singh. Welcome to this video channel Science Class 8. First, let's see contents. Chapter number 12, Friction. Let's see, it is in textbook page number 171. Okay, let's study chapter number 12, Friction. You might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. You too slow down your bicycle whenever needed by applying brakes. Have you ever thought why a vehicle slows down when brakes are applied? It is because of the friction between the brake shoe and the wheel of the vehicles. Not only vehicles, any object moving over the surface of another object slows down when no external force is applied on it. Finally, it stops. Have you not seen a moving ball on the ground stopping after some time? Why do we slip when we step on a banana peel in figure number 12.1, and why is it difficult to walk on a smooth and wet floor? So when sometime we step on a banana peel, then we fall down. It is because of the less friction. Friction between the soles of our shoes and ground is less because of the banana peel. That is why we fall down. Here, figure number 12.1, a boy falls down when he steps on a banana peel. You will find the answers to such questions in this chapter. Let's see. Force of friction. Activity 12.1. Gently push a book on a table, figure 12.2a. You observe that it stops after moving for some distance. Repeat this activity pushing the book from the opposite direction in figure number 12.2b. Does the book stop? This time, too. Can you think of an explanation? Can we say that a force must be acting on the book opposing its motion? This force is called the force of friction. Here, when we try to push a book on the table, then there is a force of friction between the book and the table. So the frictional force is opposite to the moving object. Here, figure number 12.2a and b, friction opposes relative motion between the surface of the book and the table. Next page, let's see. You saw that if you apply the force along the left, friction acts along the right. And if you apply the force along the right, the friction acts along the left direction. In both cases, the force opposes the motion of the book. The force of friction always opposes the applied force. So in the above activity, the force of friction acts between the surface of the book and the surface of the table. Is the friction the same for all the surfaces, or does it depend on the smoothness of the surface? Let us find out. Yes, the force of friction depends on the smoothness of the surface. If the surface is rough, then the force of friction is must. Activity is there. Let's see factors affecting friction. In this activity, let's see activity 12.2. Tie a string around a brick. Pull the brick by a spring balance. Figure number 12.3. this one here. You need to apply some force and note down the reading on the spring balance when the brick just begins to move. It gives you a measure of the force of friction between the surface of the brick and the floor. Here in this activity, we have to tie a string around a brick and we have to pull the brick by using a spring balance. Now wrap a piece of polythene around the brick and repeat the activity. Do you observe any difference in the readings of the spring balance in the above two cases? Say here, first we have to pull this brick by using this spring balance. Then there will be much force in between the brick and surface of this, which will be shown by the reading of this spring balance. And again, when we wrap a polythene around this brick and do the same activity, then there will be somewhat less friction. It will be learned from the reading of the spring balance. So what might be the reason here for this difference? Repeat this activity by wrapping a piece of jute bag around the brick, and what do you observe? So for this different activity, then we will get different readings from the spring balance. It is because of the friction, nature of the friction between the brick and the surface. Spring balance, let's see. Spring balance is a device used for measuring the force acting on an object. Here, spring balance, what is a spring balance? It is a device used for measuring the force acting on an object. And it consists of a coil spring which gets stretched when a force is applied to it. So, stretching of the spring is measured by a pointer moving on a graduated scale, and the reading on the scale gives the magnitude of the force. So here, so you can see the spring balance. So some readings are also there. It is marked here. So in this activity 12.3, let's see activity 12.3. Make an inclined plane on a smooth floor or on a table. You may use a wooden board supported by bricks or books. So figure number 12.4a. Put a mark with a pen at any point A on the inclined plane. Now let a pencil shell move down from this point. How far does it move on the table before coming to rest? Note down the distance. Now spread a piece of cloth over the table and make sure that there are no wrinkles in the cloth. And try the activity again in figure 12.4b. Here, this is the table, surface of the table. Here we use a wooden frame and it is kept in an inclined position by using book or brick or any material. And here it is marked as a A. Then here we put a pencil shell, and when we remove our hand, then the pencil shell will move on the surface of the table up to this, in this figure number A. And again, when we put a cloth on the surface of this table, as shown in figure number B, the same procedure we repeat. We put the pencil shell here in the mark A, then the pencil shell will move up to this. It is because of the friction between this cloth and pencil shell. And again, the pencil shell covers different distances on different surfaces. It is because of the friction. It is because of the difference of the nature of this surface. Here the pencil shell do not change. And repeat this activity by spreading a thin layer of sand over the table and maintain the same slope throughout the activity. So when we put some sand here, and the same procedure if we do again, then there is again more friction will be there. In which case is the distance covered the minimum? Why is the distance covered by the pencil shell different every time? And try to answer why and discuss the result. So the pencil shell cover different distances for this activity. It is because of the friction between the pencil shell and the surface it rolls. Here again, let's see. Does the distance covered depend on the nature of the surface on which the shell moves? Yes. The distance covered depends on the nature of the surface on which the shell moves. And next, could the smoothness of the surface of the shell also affect the distance traveled by it? And this is also yes. When we shall try the activity by wrapping a piece of sandpaper around the shell. When we are wrapping a piece of sandpaper around the shell, then we can do the same activity. So friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minor irregularities on them. In figure number 12.5, it is shown irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surfaces, there are a large number of irregularities. So, the force of friction is greater if a rough surface is involved. So here in figure number 12.5, surface irregularities is shown there. Surface of the book is here, surface of table here. Next point, let's see. Next page. We see that the friction is caused by the interlocking of irregularities in the two surfaces. It is obvious that the force of friction will increase if the two surfaces are pressed harder. You can experience it by dragging a mat when nobody is sitting on it, and when a person is sitting on it. Here we can see one activity. A boy is trying to push this box. In figure number 12.6, you have to push on the box to keep it moving. Recall your experience when last time you moved a heavy box from one place to another in figure number 12.6. If you have no such experience, get that experience now. What is easier, to move the box from rest or to move it when it is already in motion? So when it is already in motion, to move it will be easier. Let's see. The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. On the other hand, the force required to keep the object moving with the same speed is a measure of sliding friction. So, when the box starts sliding, the contact points on its surface do not get enough time to lock into the contact points on the floor. So, the sliding friction is slightly smaller than the static friction, and you find it somewhat easier to move the box already in motion than to get it started. So from this we know that the sliding friction is slightly smaller than the static friction. Next point, let's see friction, a necessary evil. Recall now some of your experiences. Is it easier to hold a cooler, that means earthen pot, or a glass tumbler? Suppose the outer surface of the tumbler is greasy or has a thin layer of cooking oil on it. Would it become easier or more difficult to hold it? Yes, it will be more difficult to hold it because it is coated with cooking oil, or because of that when we try to hold it there is less friction, so to hold it will become difficult. Just think, would it be possible to hold the glass at all if there is no friction? So at this time friction is necessary. Let's see, recall also how difficult it is to move on a wet muddy track or wet marble floor. Can you imagine being able to walk at all if there were no friction? So in a wet marble floor, when we try to walk, it will be difficult because there is less friction. So friction between the soles of our foot and ground is less. Then we will be difficult to walk on it. You could not write with pen or pencil if there were no friction. When your teacher is writing with chalk on the blackboard, its rough surface rubs off some chalk particles which stick to the blackboard. Could it happen if there were no friction between the chalk and the board? So at this time, friction is necessary. If there is no friction between the saw and the board, then it could not be written on the blackboard. If an object started moving, it would never stop if there were no friction. Had there been no friction between the tires of the automobiles and the road, they could not be started or stopped or turned to change the direction of motion. You could not fix a nail on the wall. Figure number 12.7, let's see. Or tie a knot. Without friction, no building could be constructed. So here we are discussing about the importance of friction. Figure number 12.8. Soles of shoes wear out due to friction. On the other hand, friction is an evil too. It wears out the materials, whether they are screws, ball bearings, or soles of shoes. Figure number 12.8, as we have seen. You must have seen worn out steps of foot over bridges at railway stations. Friction can also produce heat. Vigorously rub your palms together for a few minutes. Figure number 12.9, I will show you. How do you feel when you strike a matchstick against the rough surface? it catches fire. Figure number 12.10. You might have observed that the jar of a mixer becomes hot when it is run for a few minutes. You can cite various other examples in which friction produces heat. In fact, when a machine is operated, heat generated causes much wastage of energy. We should discuss the ways of minimizing friction in the following section. So here, friction between the palms, it becomes rubbing of your palms makes you feel warm, and friction between the matchstick and matchbox will catch fire. It is shown here. Next page, let's see. Textbook page number 179. Increasing and reducing friction. As you have seen in the previous section, friction is desirable in some situations. Have you ever thought why the sole of your shoe is grooved? In figure number 12.11a, let's see. It is done to provide the shoes better grip on the floor so that you can move safely. Similarly, the threaded tires of cars, trucks, and bulldozers provide better grip with the ground. Here, figure number 12.11a, soles of shoes and B, tires are threaded to increase friction. It is shown here. We deliberately increase friction by using brake pads in the brake system of bicycles and automobiles. When you are riding a bicycle, the brake pads do not touch the wheels. But when you press the brake lever, these pads arrest the motion of the rim due to friction. The wheels stop moving. You might have seen that kabaddi players rub their hands with soil for a better grip of their opponents. Gymnasts apply some coarse substance on their hands to increase friction for better grip. Okay, next. In some situations, however, friction is undesirable and we would want to minimize it. Why do you sprinkle fine powder on the carom board? Figure 12.12, you might have noticed that when a few drops of oil are poured on the hinges of a door, the door moves smoothly. A bicycle and a motor mechanic uses grease between the moving parts of these machines. In all the above cases, we want to reduce friction. In order to increase efficiency, when oil, grease or graphite is applied between the moving part of a machine, a thin layer is formed there and moving surfaces do not directly rub against each other. Figure number 12.13, it is shown here. And in figure number 12.12, powder is sprinkled on the carom board to reduce friction. Here it shows. Interlocking of irregularities is avoided to a great extent. Movement becomes smooth. The substances which reduce friction are called lubricants. So lubricants are nothing, they are the substances which reduce friction. In some machines, it may not be advisable to use oil as lubricant. An air cushion between the moving parts is used to reduce friction. Let's see. Surface 2, lubricant is here. This is the surface 1. Action of lubricant is what? In order to reduce friction. Here next, let's see. Can we reduce friction to zero by polishing surfaces or using large amount of lubricants? This question is there. And friction can never be entirely eliminated. No surface is perfectly smooth. Some irregularities are always there. So this is the answer. There should be, friction cannot be zero. Friction cannot be made zero. There should always be some friction. Wheels reduce friction. Let's see. Wheels reduce friction. You must have seen attachments and other pieces of luggage fitted with rollers. Even a child can pull such pieces of luggage. Figure number 12.14. Why is it so? Let us find out. Here, a boy is trying to pull this luggage. This is called rolling reduce friction. And next, activity 12.4. Take a few pencils which are cylindrical in shape. Place them parallel to each other on a table. Place a thick book over it. Figure 12.15. Now push the book. You observe the pencils rolling as the book moves. Do you feel it easier to move the book in this way than to slide it? Do you think that resistance to the motion of the book has been reduced? Have you seen heavy machinery being moved by placing logs under it? Here you can see the motion of the book on rollers. This is done in order to reduce friction. When one body rolls over the surface of another body, the resistance to its motion is called rolling friction. And rolling reduces friction. It is always easier to roll than to slide a body over another. And that is the reason it is convenient to pull luggage fitted with rollers. And can you now understand why the wheel is said to be one of the greatest inventions of the mankind? So, it is said that the invention of the wheel is one of the greatest invention of the mankind. Since the rolling friction is smaller than the sliding friction, sliding is replaced in most machines by the use of ball bearings. Common examples are the use of ball bearings between hubs and the axles of ceiling fans and bicycles. It is shown in figure 12.16. Let's see, figure 12.16. Here, ball bearings are shown in this picture, and here also. These are the structure of figure of say ball bearings. And figure 12.16, ball bearings reduce friction. Why we use these ball bearings in automobile vehicles? Because it reduces friction. Fluid friction, let's see. There is one more friction that is called fluid friction. You know that air is very light and thin, yet it exerts frictional force on objects moving through it. You know that air is very light and thin, and yet it exerts frictional force on objects moving through it. So, Similarly, water and other liquids exert force of friction when objects move through them. In science, the common name of gases and liquids is fluid. Actually, in science, the common name of gases and fluids is fluid. And we can also define fluid as fluid is a substance which can flow like that, which can flow. That is also fluid. So we can say that fluids exert force of friction on objects in motion through them. So fluids also exert force of friction on objects in motion through them. They also exert force. Next, let's see. The frictional force exerted by fluids is also called drag. So drag is nothing, it is the frictional force exerted by fluids. That is called drag. So drag is frictional force exerted by fluids. The frictional force on an object in a fluid depends on its speed. So frictional force on an object in a fluid depends on its speed. So speed is one important factor. So with respect to the fluid, so frictional force on an object in a fluid, it is mainly depends on its speed. So with respect to the fluid, the frictional force also depends on the shape of the object. And shape of the object is also one important factor because the frictional force also depends on the shape of the object and the nature of the fluid. Here we had been discussing about the fluid friction. It is obvious that when objects move through fluids, they have to overcome friction acting on them. So in this process, they lose energy. Efforts are therefore made to minimize friction. So an automobile would not move forward very well unless its friction was not reduced. So in this case, oil is needed to lubricate the engine and allow its parts to move easily. So oil and ball bearings are also used in the wheels, so they will turn with little friction. So here in the fluid friction also, so objects are given special shapes. Where do you think scientists get hints for these special shapes? Say from nature, of course. Birds and fishes have to move about in fluids all the time. So birds also moving in air. They also have both shape structure in order to reduce friction in the air. Likewise, fish also. Fish, they live in water. So when they move in water, in order to reduce friction in water, their shape is also both shape, which reduce friction. So they can move from one place to another faster. So their bodies must have evolved to shapes which would make them lose less energy in overcoming friction. So in order to overcome the friction, they would make them lose less energy. In order to overcome the friction, they will make them lose less energy. They will use less energy in order to overcome the friction. So they have specialized body shapes. You read about these shapes in class 6. Look carefully at the shape of an aeroplane. You know, aeroplane shape also. So figure number 12.17, you can see in figure number 12.17, the shape of the aeroplane is like this. Similarly, in shapes of an aeroplane and a bird, their shape is known as streamlined body in order to reduce friction in the air. So, do you find any similarity in its shape and that of a bird? It is somewhat similar. The shape of the aeroplane and the shape of the bird quite same. They have a streamlined body shape. So not to have more friction in the air, their body is streamlined. So in fact, all vehicles are designed to have shapes which reduce fluid friction. So things are made in a definite shape in order to reduce friction. So in the vehicles are also designed to have shapes which reduce fluid friction. So in car, boat or aeroplane also, excess friction means that extra fuel must be used to power the vehicle. Extra fuel is necessary if excess friction is there. So in other words, fuel or energy is being wasted because of the friction. So fluid friction or air resistance can greatly reduce the mileage in an automobile. So cars are streamlined to reduce friction, and birds and aeroplanes are also streamlined to reduce friction. And but driving at highway speeds with your windows open can create enough fluid friction on the car to greatly reduce your gas mileage. That is, so many things are there, they are made in a definite shape in order to reduce friction. So in all the vehicles, they are designed to have shapes which reduce friction, which reduce fluid friction. So for today, it comes to the end of this chapter. For today, let's stop here. Bye.